Hi, everybody. Good morning. Today is March 4th. So, today you have homework 8.1, 8.2, and quiz 2. Okay, everybody? Don't forget to do the quiz before midnight. And I just changed the quiz 3 due date and the exams. So this week only quiz 2, okay? And then next week is spring break, okay? And then maybe we can move the homework 3 and quiz 3 to Wednesday. So if you have questions, you can ask me on Monday and Tuesday, and then the quiz 3 on Wednesday. And then I move the exam on Monday, March 25th. So you can have more time to study for it. Okay. So I will change the due date in Canvas later. And so this is the updated schedule. Any questions so far? Mm-hmm. Okay, so let's continue. So last time we talked about the graph of 6 trig functions. And then we start to talk about, okay, what is inverse function, right? Inverse function or mirror image across the line y equals x. And in order to draw an inverse function, we have to have a one-to-one function. If the function is not one-to-one, we can restrict the domain. So we have a one-to-one piece. Then we can flip it over the line y equals x to draw the inverse function. And then last time we talked about the inverse sine function, or you can say arc sine of x. We first pick a one-to-one piece of the sine function, which is from minus pi over 2 to pi over 2. Yes, do you remember? And then we flip it over the line y equals x. So now the domain of my old function corresponds to the range of the inverse function. And the range of my function sine corresponds to the domain of the arc sine of x. And last time I teach you how to find evaluate the following values without calculator. Two type of problems. Some problems you can use your calculator, but some problems you're not allowed to use your calculator. And there are two methods to find it. One is using unit circle. The other one is use the trig graph. And then I teach you how to use the trig graph. Do you still remember, everybody? So draw the graph of sine. And then the x of the arc sine corresponds to the y of the sine. And then you just look at different y values and then find the corresponding x values. And when you draw the picture bigger, you can see, look at those common angle values. Pi over 6, pi over 4, pi over 3, and pi over 2. Do you see the angle is increasing? And then the y values, 1/2, root 2 over 2, and root 3 over 2, and 1. They're also increasing. So you can use this to find the corresponding x values. Any questions about this part? So we use the same idea to generalize to other trig functions. So let's look at them one by one. Okay, so we did the sine. Now let's look at the cosine. Cosine graph is like wave, right? And it starts from 1. So it goes like this. This is the cosine x. In order to find the inverse function, we need a one-to-one piece. So the one-to-one piece we use is here from 0 to pi. From 0 to pi, this piece is 1 to 1. So this piece, 0 to pi, is 1 to 1. And then we flip it over the line y equals x. Therefore, the light blue curve is the arc cosine of x. Okay, and as usual, the domain of f corresponds to the range of the inverse function. So look at the cosine. So domain of f is the cosine. Do you see the domain? The x values is from 0 to pi. Yeah, look at the cosine. Domain is 0 to pi. And the range, what's the range? The y values is from where to where? -1 to 1. So therefore, the domain of inverse is corresponds to the range of the function f. So now the domain of inverse is -1 to 1. You see the light blue curve is the arc cosine, and it's from -1 to 1. And the range of the arc cosine corresponds to the domain of the cosine. So that's why it's from 0 to pi. Okay, everybody? So this is how we draw the arc cosine. You pick a 1 to 1 piece of the cosine function, and then you flip it over the line y equals x. Any question up to now? All right. So note on the graph of the inverse cosine function. The inverse cosine function is decreasing and continuous on its domain. Right? It's going down, so it's decreasing. The x-intercept. Yeah, we have an x-intercept. And this is the 1, 0. And we have the y-intercept. The y-intercept is 0 pi over 2. Okay, everybody? And the inverse cosine function is neither odd nor even. Thank you. Because look at this. Is it mirror image about is this a measure with respect to the y-axis? No, right? It's not symmetric with respect to the y-axis. Because give me any point on the graph, you flip it over, it's not on the graph. Yes? And is it symmetric with respect to the origin? Give me a point here, and I rotate 180 degrees. Is it on the graph? No. So this is neither odd nor even. Okay, everybody? So this is the inverse cosine function. Now, how do we find the following values without calculator? Okay, so yeah, take notes. This is how we find the arc cosine values without a calculator. And also two methods. One method is use the unit circle. The other method is use the trig graph. Okay. And I'm teaching you how to use the trig graph. Okay. So if you see arc cosine, you draw the graph of cosine. So cosine is from 0, okay, to 2 pi, and it starts from 1. Okay, maybe I start first. And this is -1, and this is pi over 2, 3 pi over 2. So this is cosine x. By the way, today, at the end of the class, you will practice this worksheet. You will fill out the values of this worksheet. Yes? Do you still remember this worksheet? Sine, cosine, the way. The sine start with 0 and cosine start with 1. The theta value is the 5 numbers spread over the interval from 0 to 2 pi. And tangent, period of tangent and cotangent, they're all pi, right? And tangent looks like x cubed, cotangent is like you flip it over, right? And cotangent is from 0 to pi. And then secant, cosecant. Secant is 1 over cosine, so you kind of draw the cosine and you flip it over. So it's up, down, right, everybody? And secant is 1 over sine, so you also flip it over, so up, down, up, down. Okay, everybody? Yes, you will practice this worksheet at the end of the class. Okay. So, we draw the graph of cosine. And now you keep in mind that x of the cosine corresponds to the y of the cosine. So keep that in mind. And now, because we're looking at the special angle values, you actually need to draw more. So we know in the first quadrant, thank you. First quadrant corresponds to the angle from 0 to pi over 2, right? In the middle is pi over 4. Yes, pi over 4. Pi over 4. And then if you divide it into 3 pieces, so 0 and pi over 2 divided into 3 pieces, what is this guy? Pi over 2. 6. Yes. Pi over 6. And how about this point? 3. Pi over 3. Yes, everybody? And now you kind of draw it. Okay, that corresponds to here. And let's see. This one corresponds to here. And that one corresponds to here. Let me draw better. Okay, and then you know the values. It starts with 1, and then the number smaller than 1 is root 3 over 2. And then the next number is root 2 over 2. And then the next number is 1 half. So once you draw the picture, it's very easy to see because your x values is increasing, right? And your y values is decreasing. So the biggest is 1, and then root 3 over 2, and then root 2 over 2, and then 1 half. And then 1 half you can see is about half of the work. Okay, everybody? So draw this picture and draw it bigger so you can see the x and the y values of the first quadrant. Okay, now let's look at this. The first one is root 3 over 2. And you know our cosine, the angle, so the range of our cosine is from 0 to pi. Okay, that is the range of our cosine. So part A here is like the x of the arc cosine. It corresponds to the y of the cosine. So you kind of let y is root 3 over 2. And you want to find the x in the angle interval 0 to pi, such that the x maps to the root 3 over 2. And you can see from here to here, that angle root 3 over 2, that's the y value. It corresponds to the x. What's the x? Pi over 6. So the x is pi over 6. Okay? So we got x is pi over 6. Therefore, our cosine of root 3 over 2 is pi over 6. So this is how we find the values without calculator. And in the exam, you need to show all your work. So you need to draw the graph, and you draw the common values in the first one. Is that clear, everybody? All right. So this is part A. We set the y value is root 3 over 2, and then we find the x. Part B. So part B, let's use green color. So we set the y is negative 1/2. This is negative 1. Negative 1/2 will be here. Do you agree, everybody? So negative 1/2 is here. So you put the horizontal line, and do you see this point? This y is negative 1/2, and we want to find the x. We want to find the x. So what is this x? Okay, here is the trick. You know, this is pi over 2, right? This is pi. The middle one will be what? The middle one will be 3 pi over 4. Yes, everybody? And then here, do you still remember reference angle in chapter 7? Reference angle is the angle with the terminal side and the x-axis. Okay, so that the reference angle is also the difference between the pi, the difference away from the pi. So like an angle here, 3 pi over 4, the reference angle will be pi over 4. Okay, and here, our common angle value will be, you divide this into 3 pieces. So you have here and here. And then this one will be, okay. So here, the trick is, this is 0, this is pi. If you divide into 6 pieces, your denominator is 6. Right? And if you divide into 4 pieces, your denominator is 4. If you divide it into 3 pieces, the denominator is 3. So then this number corresponds to the 3 pieces. So the denominator is 3. So then this side is 2 pi over 3. Right, everybody? It's 2 pi over 3. So this is 2 pi over 3. Or you can imagine the reference angle. The reference angle, you look at the y value. No, the y value is negative 1/2, and the absolute value of that is 1/2. So then the reference angle is pi over 3. So therefore, this angle, if you want to use the reference angle, you're doing pi minus pi over 3, which is 2 pi over 3. So if you want to use the reference angle, okay? But if you don't want to use the reference angle and just look at the graph, this is roughly 2/3 of a pi. So it's 2 pi over 3, okay? And then the angle bigger than 3 pi over 4 will have a denominator, 6. So this guy corresponds to 5 pi over 6. And if you want to use the reference angle is pi over 6. So in the graph, first quadrant is 0 to pi over 2. Second quadrant is pi over 2 to pi. The third quadrant is pi to 3 pi over 2. The fourth quadrant, 3 pi over 2 to 2 pi. Yes, everybody? And the reference angle. Reference angle is always between 0 to pi over 2, is an acute angle. And then the width, okay, you look at the reference angle is like how much away from the pi. So in the second quadrant, your reference angle is pi minus the actual angle. And then in the third quadrant, your reference angle is the actual angle minus pi. If you can still remember from chapter 7, where we talk about the reference angle. So therefore here, y is negative 1/2, then the x is 2 pi over 3. Okay, so we find the x in 0 to pi, and we can see x is 2 pi over 3. Okay, you tell me the next one. Yes, this one is easy because it's positive. It's positive, then it's in the first quadrant. So root 2 over 2. Okay. Let's use blue color. Let y is root 2 over 2. And we see the corresponding x. So x in 0 to pi over, 0 to pi. You find the x in 0 to pi. And then we get x is pi over 4. Is that okay, everybody? So once you draw the graph, and then you can find the values. All right. Any questions so far? How about next one? What is a cosine of 2? Nothing. See, if you put the 2 here, it does not intersect the graph. Okay? So this one is undefined. Okay? Because your y cannot be 2. Any questions so far? So we draw the graph and then we can figure out the values. Okay. And usually what I do is I know the midpoint is gonna be pi over 4 or 3 pi over 4. And then the smaller angle is always pi over 3. Here the bigger angle, pi over 3. And then here the bigger one is more closer to the pi, so it's 5 pi over 6. And then the smaller than 3 pi over 4 is gonna be 2 pi over 3. So this is how I find the values. And remember. Okay, so this is the arc cosine. Let's continue. Tangent. All right. What's the graph of tangent? Yeah, like x cubed. Oops. Okay, so it's from negative pi over 2 to pi over 2. And do you see this guy? It's 1 to 1. Right? This piece is 1 to 1. So we use this piece, flip it over the line y equals x. Sorry, the color is not so clear. But this is the tangent, and then this is the tangent. Okay, everybody? So now you can see the domain of the tangent. Okay, so let me put domain of the tangent is from negative pi over 2 to pi over 2. The range of the tangent is minus infinity to infinity. Yes, everybody? And now the domain of the inverse tangent corresponds to the range of the tangent. So it's from minus infinity to infinity. And the range of the inverse tangent corresponds to the domain of the tangent. So it's from minus pi over 2 to pi over 2. Look at the graph. This graph is the arctangent. The domain, all values, all real numbers. The range is from minus pi over 2 to pi over 2. Okay, everybody? Yes. All right, note on the graph of inverse tangent. The inverse tangent is increasing and continuous on the domain. Yeah, look at this graph. It's increasing. Both the x and y intercepts are 0. Yes. And we have horizontal asymptotes. So these were vertical asymptotes. But when you flip it over, it becomes horizontal asymptotes. And furthermore, you can see the graph is symmetric with respect to the origin. Yes. So it's symmetric with respect to the origin. So y equals the arctangent x is a odd or even function. Symmetric with respect to the origin? Odd function. Very good. Okay, now how do we evaluate the following expression? Draw it. Okay. You see, I don't need to draw the inverse tangent, just draw the tangent. So draw a big tangent. Negative pi over 2 and pi over 2. And keep in mind that x of the arctangent corresponds to the y of the tangent. That's why you only need to draw the tangent, and then you set your y values to be different number. Okay? But here we need more numbers. So look at here. The first quadrant. Again, 0 pi over 2. The midpoint is pi over 4. Yes? Right? And tangent pi over 4 is what? Tangent pi over 4. Tangent pi over 4. 1. Yes. Okay. So this is 1. And then you divide this into 3 pieces. This is pi over 6. This is pi over 3. Is that okay, everybody? Now, look at the numbers. So here, pi over 6, it corresponds to this guy. And here, it corresponds to this guy. Okay. The special angle values, you know, it's 1 root 3 and 1 over root 3. Root 3 is bigger than 1, right? And 1 over root 3 is smaller than 1. So therefore, the number bigger than 1 is root 3. And the number smaller than 1 is 1 over root 3. Yes, everybody? So we draw it. Now we can figure out the values. Okay, so we let the y equals root 3. And our angle. Okay, we find the x in, you see, is in minus pi over 2 to pi over 2. And what is the x? Yeah, y is root 3. The x is pi over 3. Is that okay, everybody? Okay, now you find the next one. About arctangent. What's your answer? Pi over 4. Yes. Okay. So yeah, in the exam, I hope you show all your work. So draw the picture and tell me how you think. So you're letting y equals 1, and then you find the x in negative pi over 2 and pi over 2. That satisfies this. And you get the x is pi over 4. How about arctangent, negative 1? So do you see here, if this is 1, a negative 1 will be here, right? Everybody? Yeah, this is 1, and this is negative 1. So we draw the negative 1, and let's see. We put it here. Okay. I think my graph is not so good. Because you can compare the numbers here. When we have 1, it corresponds to pi over 4. So negative 1 should be corresponds to this guy. So it should be corresponds to here. Right? So my graph is not so good. Let me put the negative 1 closer. Okay, so like here. Then we know this is negative pi over 4. Okay, so keep in mind, negative 1 corresponds to minus pi over 4. Because this is symmetric with respect to the origin. The reference angle is like pi over 4. Okay, so that here is negative of that. So we get so y equals negative 1, and then we get the x is negative pi over 4. Is that okay, everybody? All right. How about arctangent, square root of 2? Okay, square root of 2 is not a common angle value. Okay, our common angle values are like 1 over root 3, 1, and root 3. So then if you see other numbers, you are allowed to use calculator. So use calculator. And make sure you are in radian mode. Okay? Make sure you're in radian mode. So take out your calculator. Do you see the button arctangent? You need to press shift and then tangent. Do you have calculator? So what is arctangent of square root of 2?
0.9.
What?
0.95.
Oh, give me 4 decimal places.
53.
53. Okay. Thank you. Do you all get the same number? Okay, good. All right. Questions. If I ask you, okay, what is arctangent negative square root of 2? By symmetry, you kind of expect this value to be negative here. Right, everybody? Hey, do you remember that our negative angle values for tangent? Because this is a function, the negative, you can pull out the negative. So it'd be negative 0.9553. That's because it's an function. They still have the negative sign, right? But if you see like cosine or secant, they eat the minus sign. But if they actually inverse cosine, you gotta be careful, okay? Because for example here, the inverse cosine is not from negative pi over 2 to 0. It's actually from pi over 2 to pi. So that's why you cannot just put the negative in front of the values for the inverse cosine. You actually need to look at the graph and figure out the angle values. Is that clear, everybody? Okay, so let's continue. We learn sine, cosine, and secant, tangent, and the inverse functions of those three. And then the remaining, we have cotangent, inverse cotangent, inverse secant, and inverse cosecant. Okay, so when you see this, okay, you kind of try to relate to, so you want to relate to the, okay, let me see. When you see inverse functions, you try to relate to the inverse sine, inverse cosine, and inverse tangent, and inverse cotangent. Okay, because if you see inverse secant, this is related to the inverse sine. So if you see inverse secant, okay, and what is this? You think about, okay, if I let this is y, this also means that uh, the x equals secant of y. Okay, because they're inverse functions. This is the input, then it now it corresponds to the output of the secant. The y was the output of the cosecant. Yes, sorry. The y is the output of the inverse secant, so now is the input. So it's like they are equivalent. Mhm. And now if you do 1 over x, so you look at the reciprocal. Reciprocal of the secant y is cosine y. So therefore, the y is now the arc cosine of 1 over x. So if you're not familiar with the arc secant or arc cosecant, it's okay. You can transform it in terms of arc cosine or arc sine. So similarly, if you see arc cosecant, this gonna be, any guess? Yeah, arc sine of 1 over x. Exactly. Because sine and cosecant, they're reciprocal. So that's why you're gonna flip it. Okay, so let's do the following. Okay, find the following without a calculator. Okay, so if you have arc cotangent, then you still need to draw the graph of cotangent. Okay, so let's hear what's the graph of cotangent. You kind of flip the tangent over. So this is y equals cotangent x. And then here is pi over 2. And then the middle is pi over 4. And you cut it into 3 pieces. This is pi over 6 and pi over 3. And oops, sorry, I don't mean to erase it. And pi over 4. What's cotangent pi over 4? 1. And then you see the other angle values corresponds to here and here. The number bigger than 1 is going to be root 3. The number smaller than 1 is 1 over root 3. Yes, everybody? This is how we draw the graph of the cotangent. Now, you see, we let the y equals square root of 3. Yes. And then what is the, okay, so you let y be square root of 3. And what is the cotangent? What's the x value? Yeah. So we find the x in here is 0 to pi. Okay. And now it's 0 to pi. That is also the range of the arc cotangent. Then we get x is pi over 6. Is that okay, everybody? Mm-hmm. Let me ask you more because I want to ask you like more. If if I ask you a cotangent of -1, what do you do? -1. This is 1, right? -1 will be here. So we go down. That's -1, and then whoops. Let me see. Oh, so maybe upper because the length is like this, so it's about like this length. Okay, this length. That's -1, and then you draw here. Okay, do you see this guy is like about the middle? The middle is what? 3 pi over 4. So this guy, it corresponds to 3 pi over 4. -1. You get 3 pi over 4. That's the middle. And if I ask you more, if I ask you how about a negative in arc cotangent of -√3, it would be -√3 here. So this corresponds to what? Uh, this okay. This is pi over 2 to pi. You cut into 3 pieces. This is gonna be 5 pi over 6, and this is 2 pi over 3. Everybody clear? Yeah, sometimes maybe it's good to practice. So this and this is gonna be 5 pi over 6. And that one is 2 pi over 3. Okay? And this is all the probability I will ask you. Okay? Either root 3, 1, or 1 over root 3, or -1 over root 3, -1, or -root 3. Okay, everybody? Okay, so this is the arc cotangent. Okay, now good. If you see arc cosecant or arc secant, you just relate it to the arc sine and arc cosine. You don't need to remember the 6. You just need to remember 4. Okay, so let's work on this. Okay, so this guy, and we look at let me see. Oh, okay. I know what's wrong. Okay, mine is the older version. Like, where's oh, okay. Yes. Okay. So your worksheet looks like this, right? Oh, okay, okay. Same one. Your is the older version. So the order is a little bit different. Okay. All right. So if we see cosecant this is cosecant, then we convert it to sine. It will be 1 over that values, right? We're using this formula. Okay? So it's outside, and we'll flip it over. So we flip it over, we get a sine of, what do you get? Root 3 over 2. Yes, everybody? That's why I said if you see cosecant, convert it to sine. And now sine, you draw the graph of the sine function. And it looks like this. Okay. And you're now from negative pi over 2 to pi over 2. Okay, negative root 3 over 2. Okay, so where are we? This is, okay, this is -1. This is 1. Okay, so this is the sine x, And you know x of the x side corresponds to the y of the side. So you let y equals negative root 3 over 2. It's negative. Then can you imagine it's going to be from minus pi over 2 to 0? Yeah? And if you can draw this bigger, you now imagine the middle. The middle is negative pi over 4. It corresponds to the value negative root 2 over 2. And then you cut it into 3 pieces. This is negative pi over 6. It corresponds to negative 1/2. And this is negative pi over 3. It corresponds to, sorry, I should draw it bigger. Negative root 3 over 2. So have this picture in your mind. Yes, everybody, your x is getting smaller. So negative root pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. They're smaller. And then your y values are getting smaller. Negative pi, negative 1/2, negative root 2 over 2, and negative root 3 over 2, and negative 1. So therefore, negative root 3 over 2 corresponds to, what's your x? Yeah, x is negative pi over 3. So we let y be negative root 3 over 2. And we get the x is negative pi over 3. So the side of negative root 3 over 2 is equal to negative pi over 3. Okay, everybody? So this is how we find the inverse cosecant values. Sorry, we didn't have a time to test on the worksheets. Let's do that next class. Okay? So yeah, if you're not familiar with this worksheet practice, let's do it next class. And in the middle, maybe we shouldn't keep it at the last. Yeah. Oh yeah.
We should do it before.
Before, yeah, yes. But some students come in late. Well, maybe when the alarm.
They can stay after that test because I wasn't able to find it. So
Oh, okay. So it's on the website, and you go down.
Okay, it's all the way up.
Yeah, under the.
So I was not able to get that done. I will try and get that.
Okay, sounds good. Thank you.
So ask you a question about this. Why is it 3 pi over 4?
Oh, okay. So this is the middle of it, and you know math all of this. Pi over 2 is like 2 pi over 4, and pi is like 4 pi over 4. So the middle between 2 pi over 4 and 4 pi over 4 is 3 pi over 4.
That's easier.
Bye. Question?
We're not gonna be here for the rest of the week. We're going to nationals for hockey.
Oh, okay. So I see. So you're not able to do this one. So do you have time to come to my office to fill this out?
Today, maybe.
Today?
Maybe, yeah.
Yeah?
When are you in there?
From 11 to 1:50.
Yeah, I should. Be able to. We come at the same time.
Yeah, we can do that.
Yeah. That's
Okay.
good, yes. So I just want to make sure you're familiar with this formula.
Okay.
And then feel free to watch recording and ask me questions.
All right, thank you.
And good luck.
Thank you.
Hi, Susan.